spin statistics, so very singlet in nature, physics coming to the picture. When these excitons generated, you remember the fluorescence, phosphorescence. How many of you remember fluorescence and phosphorescence? You don't know? Okay, fluorescence and phosphorescence both are emission process only. I told now when the molecule goes to the excited state, when they come to the ground state, they release the energy. No, it is all depends upon where the energy is coming from. Okay, so it is like, for example, you are going to Vijayawada. Okay, currently you are in Madhu Atla now. Either you can go to through Guntur or you can directly go to Vijayawada also, right? So it is all depends upon like that. So for example, S1 is Madhu Atla, T1 is Guntur, S0 is Vijayawada. Either you can go directly from S1 to S0, that process is called fluorescence, or S1 can be transferred to T1, from there the emission can happen. Okay, this is called phosphorescence. Okay, so fluorescence means it is a singlet to singlet, so that emission process is much faster in the sense it is in the scale of nanoseconds. Okay, so where you see this kind of a process, fluorescence means so like we have some dyes now. For example, when you are wearing the colorful dresses, okay, that is made up of some dyes. These dyes gives the fluorescence, because when you sit under the light, those molecules absorb the light and giving the indigo color. Okay, so that is what happens with the dyes. In the case of phosphorescence, that emission is not a spontaneous one. It takes time, because it has to go to Guntur, it has to get the bus, then only it goes to Vijayawada. So the phosphorescence is little slower one. Okay, so the problem is we don't want phosphorescence, we want only fluorescence, because we want spontaneous emission. But the problem with these dyes is, as I told, the spin statistics, we have 25% only on the singlet state, 75% on the triplet states. Okay, so that is a problem in the efficiency. Okay, for example, we have this many students. If whatever I told, only 10% people observe, it's a waste of efforts. If everybody understand, very good efforts. So same thing, we injected the charges, but we are getting only 25% fluorescence. That means it's not a very efficient device, correct? So that is the reason the first generation dyes has the internal quantum efficiency of only 25%, because 75% will be on triplet state, which will be emit as a phosphorescence, which we don't want. Okay, so this is the problem with this thing. So there are some scientists which continuously put efforts to improve the society now. So those scientists, what they have done is, they introduce a concept called, why we have to use only 25% of singlet states, let's make everything into the triplet state. Okay, so generally triplet state, as I told, it's a phosphorescence, but still they made it as a 100% process through intersystem crossing. I think when you study the Jablonski diagram in your organic chemistry or spectroscopy book, you will understand that there are many processes. It is called intersystem crossing. Through the intersystem crossing, the 25% singlet excitons converted into triplet states. So we get now 100% in the triplet state. So this will come as a phosphorescence. But the problem with this phosphorescence is, in order to get the intersystem crossing, we have to use some metals. It's an expensive process. Basically, we don't want much phosphorescence also. So that is why, so there are new type of materials has generated, which is introduced in Japan. Okay, so what that guy has proposed is, instead of sending singlet to the triplet, we take excitons from triplet to the singlet state. Okay, so in order to do that, because in chemistry, going up to down is very easy, because it's a spontaneous process, correct? Going from higher energy to lower energy is always spontaneous according to our thermodynamics. But going up to down to up is a up conversion is always is a thermodynamically not a feasible process. So in order to make the thermodynamics into easier, what people has proposed is the energy gap between the singlet state and triplet state should be very, very small. Okay, it should be very, very small. So even the room temperature is sufficient to take them to the singlet state. So that is why the energy gap delta EST, that means energy gap between the singlet state and triplet state should be very, very small, so that the triplet can be up converted to the exit state. So this is called, previously we called ISC, inter-system crossing. Since this is going from down energy to the higher energy, this is called reverse inter-system crossing. Okay, so we get the reverse inter-system crossing. Now we have 100% on the singlet state, so we get 100% fluorescence. So this is, now we get the internal quantum efficiency of 100%. So overall, if you see, so we have 25% on the singlet, 75% on the triplet. Through the inter-system crossing, we made all 100% on the singlet state. Now we get the fluorescence, much efficient than the previous existing systems. Okay, so as I told, the fluorescence happens in the scale of nanoseconds, but the fluorescence, delayed fluorescence will be little slower on the scale of microsecond, because you might have understood the triplets has to go to the triplet singlet state. Again from the singlet it has to come to ground state now. So it is a little slower process compared to the spontaneous emission. So this is the process happens in the this emitters. Okay. So the overall challenge here is there are big equations. It is I can understand it's difficult to at this stage, but the overall the point here is we have to design a molecules. Okay, that molecules first criteria is should have a smaller energy gap between first singlet state and the triplet state. That is first challenge, and it should spontaneously come from higher energy to the lower energy. Okay, so these are the two conditions we have to design the molecules. So how we will be more useful, because how experimentalists or anyone doing research or synthesizing the molecules, everybody has some target in their mind, correct? With some target only we do anything. For example, if in our case exams are the good marks is the target, or getting into the higher positions is a target. With that mission only we do everything. So in the case of moleculars also, our target is properties. We want to have a molecules with these properties. So what experiment has to do is they have to synthesize these molecules, okay, and they have to characterize. For example, all the reactions whatever we do, we think it will not happen now. So we make it different types of products. Okay, so all this process is a time consuming. We need to buy chemicals, and we need to invest time, money, efforts, everything. Okay, without doing all these things, what if someone told using the computers, okay, we can study the molecules and we can tell, okay, you take these 10 molecules. These 10 molecules might have all the properties that you are looking for. Now you synthesize only the 10 molecules. Otherwise, you don't know from where to start. You have to synthesize the library of molecules. Within that library of molecules, only few may work, or may not work also. So the computational chemistry can act as a pre-screening to any properties. For example, we have in the case of drugs also, we are using many medicines. How do you know only this medicine works? You know that they have to search millions of molecules. Within the millions of molecules, they choose some 100 molecules. Pre-drug test. Within that 100 molecules again, they see the toxicity, and when you take that medicine, it should not impact the other functionalities. All these things they do. First, this is the first level. And the second level, they do these experiments on the animals. If the animals case it succeeds, then they will come to the human trials. After the human trials, then only the drug will be approved. So You see, they started with the millions of molecules and finally ending up with one potential molecule. So if they do rely only on experiments, it is very difficult and time consuming process. So that is why the computational chemistry or artificial intelligence or machine learning can exploit the identifying the molecules, the potential molecules. So that is what basically we do research. But most of the things what I show now, I think if you are interested, we do the virtual screening. This is called virtual screening. Why? Because without doing experiment, we are trying to identify the properties and we are trying to filter in the best molecules. Okay, so it is like our campus placements. Some campus guy, for example, Infosys come. Do you think the Infosys guy will take all of you? You do his screening test, right? Because he is looking for some properties. In your case, the properties are you should be hardworking, you should have expertise. Okay, so that is his criteria. So based upon that, he is screening you. Same way, in the case of molecules, we have thousands of molecules. What actually we want, that we are trying to take it from this set. Okay, so I will show you some systems how we do that. So this is the system. We take the molecules, something called donor and acceptor. So that means these are not the money donors or money acceptors. These are electron donors and acceptors. For example, if I want to say simple thing, benzene is there. Benzene is electron donor acceptor. Benzene, you know, right? Chemistry. You know, right? Benzene is electron donor acceptor. No, benzene as it is, it doesn't donate, it doesn't accept. It's a benzene only. Okay. So when you add benzene to aniline, okay, amine group. Aniline, you know, right? Aminobenzene in a simple language. Now tell me, you have a benzene ring and you have a amino group. Now tell me which is electron donor, which is electron acceptor. Yes, very good. So amino group is electron donor, benzene act as an electron acceptor. Okay, now let's replace amine group with nitro group. In this case, which is electron donor, which is electron acceptor? Nitrobenzene. Very good. Nitrobenzene. In the nitrobenzene, nitro group accept the electrons. Now benzene donates the electrons. So you see, it depends upon the functional groups. The same groups may act as a donors, may act as a acceptors. Okay. So the entire chemistry depends upon inductive effect, mesomeric effect, and hyperconjugation. These three, if you understand these three, you can understand any concept in chemistry. Okay. So this, based upon this donor acceptor concept, we choose the molecules. You might have asked why we have to take one donor and one acceptor. We can do everything with one donor. The reason is to control the band gap. Band gap means energy levels. For example, you want blue light for your watch. You want to have a blue light. So, if you want to get the blue light, molecules has to emit the blue light. Correct, no? In order to get the blue light, now you think. Okay? Now, in order to get the blue light, okay, you should have a energy levels, longer energy levels or shorter energy levels. Think from the electromagnetic spectrum point of view. Shorter energy gap means higher wavelength. Correct? Shorter the gap, larger the wavelength. Based upon what principle? Based upon what equation? E is equal to
lambda is equal to hc by ec. E is equal to h nu.
E is equal to h nu. Who proposed this? De Broglie. Einstein.
Planck's quantum.
Planck's.
Planck's quantum.
It's a Planck's quantum theory. E is equal to h nu. Okay. So the relationship between energy and the wavelength is inverse relationship. Okay. Frequency is directly proportional. Wavelength is inversely proportional. So in your Vibgyor spectrum, where is the blue light? Is the shorter wavelength or longer wavelength? Shorter wavelength. So we should have a larger band gap materials. So in order to get the larger band gap, the donor should be weaker donor and weaker acceptor. If we take a stronger donor and stronger acceptor, energy levels are shorter, so we get the longer wavelength. For example, if you want to get the red light, we should take stronger donor, stronger acceptor. The energy gap will be smaller, wavelength will be longer. Okay? So this is how the emitters control the what light we see, how brighter we see. Okay? Brightness also important, no? Will you buy a mobile phone which gives the very poor colors? No, right? In a home also, we want the very contrast and dynamic colors. Correct? How the colors are coming, how the sharpness. Okay? So all these depends upon the color purity, the stability. Will you buy a TV? It works for only one day? No, right? If your mobile phone works for only 10 days, you will buy? No. We should have a longer life also. Okay? All these things are important when we think of some molecules. Okay? So I told you how molecules decides the display fate. So likewise, so we need to identify the molecules which show all these properties. Okay? So these are like a little deeper. It's not very deeper, but I think if I see the faces of you, I'm not much interested. So depends upon the type of molecules we take, we get different types of properties that decides the important aspects that we are looking for. So as I told, the energy gap between the singlet state and triplet state is very important now. That is the TAD of efficiency. The TAD of efficiencies depends upon those two factors that we choose based upon particular properties. Okay. So it is like this. You see the different nice color balls. Those are not color balls. Those are the orbitals. So if that whatever the singlet state and triplet state, that nature decides the how faster the intersystem crossing happens, the spin orbit coupling, all these things decided. So we get faster rate based upon the oscillator strength, all those things. Okay. So basically, we have a targeted properties. We choose the molecules based upon these pre-decided properties. Okay. So we also study molecules vibrate. No? Does molecules vibrate? Yes. So during the vibration, they lose the energy. That is called non-radiative decay. We try to measure also how we lose that energy based upon these equations and these softwares. So basically, we try to identify the best molecules based upon these properties. So you see, the first one is the energy levels, and the second one is where the energy gap is there, that decides the color, and the third one is how the surrounding molecules. Like for example, now we have a group of students. Now I see, even if you are trying to listen, your friend may tell some story. You will ask, what is how about Ustad Bhagat Singh? How does it happen? Even you are listening, he will disturb. That is called surrounding effect. Okay. So if you are alone, your behavior will be different. If you are with a classroom, your behavior will be different. The moment the front row is not there, your behavior will be different. So it's all depends upon the medium effects. Okay, how does it impact the properties that we are looking for? Okay, and most importantly, the fourth one, this is the color purity. Okay, so the color purity is depends upon how sharper the emission light. Okay, how, if I want to tell very simple word, for example, if I synthesize a molecule, it will have only one molecule inside the beaker. If you take one liter of water molecule, sorry, water bottle, how many water molecules will be there? Avogadro number. More than Avogadro number, because it's a 1 liter water, right? So it will have more 10 to the power of 23 water molecules. So same thing, if one water molecule emits the light, imagine something like that. Okay, it will emit in certain region. You have a 10 to the power of 23 water molecules. So you will not get all water molecules at a time won't release the energy. Some water molecules releases now, some release later. So you don't get a short emission peak, you get a broader emission peak. So that decides the color purity. For example, instead of getting exactly at 500 nanometers, some may emit at 490, some may emit at 510, some may emit at 520, because the energy levels keep on fluctuate now. As you told, the vibrations, because of the vibration there will be a change in the position of energy levels. So all these factors impacts the color purity. Okay, you don't get exactly the red, you may get a lighter red, darker red. So that purity also important for the molecule. So for that we have to make molecules more rigid. Okay, so when we make rigid molecules, you don't see such kind of fluctuations, you see the more sharper peaks. So we have our own targets. So with these targets, we design the molecules. So as I told, we take a donor and acceptor type of molecules, and here we have taken coralline kind of a molecule. Coralline means, I think you know the fullerene. So it's a fragment of fullerene. So with that we try to introduce different functional units so that we can change the color. So you can see here. So it depends upon the type of units that we take. We get the color emission from 400 nanometers to 946, which is actually in the red region. So we get the blue, yellow, green, orange and red type of emissions. Okay, so this is the type of molecules that we design, and we also study the different types of mechanisms within the molecule, like why the upconversion happens from the T1 state, why not from the higher excited states. So likewise we in detail study all the molecular properties, like here. So here the whatever the upconversion that I told, it is not only from the T1 to S1, it can happen from the higher excited states. So in order to achieve that, we have taken a different type of molecules. That molecules show these kind of properties. So this will give some additional advantage for us. So because of the upconversion, I told you we have taken donor and acceptor type of systems. So that gives the lower oscillator strength. Now because the upconversion happens from the higher excited states, so we get a little flexibility with respect to oscillator strength design. So we get a better type of systems here. So that is what we have done here. And the near AR emission is very, very important for the night vision and the lasers and for biological applications. So getting near AR emission is difficult because we should have a smaller energy gap. So what we have done is we have taken a molecules which show the extended conjugation within the molecule. So when the conjugation is there, the pi electrons are delocalizing more within the molecule, we get the smaller energy gaps. So for example, if you take a benzene, it will have one certain type of a gap. When you attach nitrobenzene or aniline, because of the conjugation is increasing now, so the gap will be reduced. So likewise, we are trying to induce the emission in the conjugation in the molecule, so we get the smaller energy gap in these molecules. So we got the larger emission. You see here we got in the range of 900 nanometers. That is the range we got with the smaller energy gaps. So we studied all the properties of these molecules. And I told we also studied how the surrounding molecules impacts the properties. So for that, what we have taken is, we have taken only one molecule, and we have taken the molecule surrounded by same molecules. It's like more number of molecules, and we compared the properties. The same molecule, how we are getting the properties when we have the molecules surrounded by same type of molecules, how these properties are different, whatever that we are looking for. So for that, we have taken different types of computational methodologies. So we have studied these systems in detail. So you can see here the comparison. Gas means only single molecule. Solvent means same molecules, but the direct constant will be there. Amorphous is like a real presence of the real molecules. So how the presence of molecules suppresses the molecular flexibility in this molecule. You can see that RMSD is a root mean square deviation between ground state and excited state. So if you see the higher RMSD value, it has a lot of flexibility, because when the molecules goes from the lower excited state to the higher excited state, there will be a change in the molecular structure. Okay, so the more change in the molecular structure, that means you are causing the more energy loss. Okay, so that energy loss is more in the gas phase. But the moment when you go to the amorphous, that means the presence of other molecules, that is came down to 0.014. So that means presence of these molecules, it doesn't have much flexibility to change the structure. So we can suppress the energy losses in the presence of the other molecules. So that is what we identified, and we have quantified how the emission wavelength changes when we go from single molecule to the multiple molecules, and we calculated the rates, how the photophysical processes rates affects all those things. And so we see a different scenario in 3 different cases. So we also try to visit the molecules, and we got the better thing. The most important thing is, as I told, experimentalist is basically do the innovation of molecules using the trial and error approach. Trial and error means, like for example, you want to synthesize you want to find a molecule which reduces the headache. Basically, it's a paracetamol. To identify the paracetamol, we cannot directly go to the paracetamol now, so we have to search the different types of systems. So that is what. So when we try to find the different type of molecules, that is a trial and error method. Okay. So it is similarly when you open a Netflix or Amazon Prime. Do you know whatever the movie that you are going to see is a good movie? We don't know. After watching only we will come to know. This is a trial and error movie. Okay. When you try only, you will get whether it's a good movie or a bad movie. So same thing. Experimentalist also will do all those things. For example, in the case of OLED, the emitters, degradation, durability, and cost is the bottlenecks. How much the QLED TV today? Very expensive. Why? It is because why expensive is the type of materials that we use in the displays are very expensive. That is why cost is very high. So if you identify your molecules, cheaper molecules which shows the properties, the cost will come down. So these are the important properties that we want, and we need to identify these type of molecules. Okay. So for that, how you explore, that is the most important thing. So for example, if you have a laboratory where you implement this kind of a machine learning or artificial intelligence type of system, what we can do is we can start a kind of a loop. So first we should have a, for any machine learning kind of a thing, we should have a data. Okay. So I hope you know in last 2 days you understand, you might have understand what is meant by machine learning. Machine learning means we see the pattern. Okay. So for example, you are coming from home, daily home to college. If you take one route, okay, daily for last 1 year you are following the same route. Okay. So that is the information. For example, today morning 9 o'clock, what you do? You start from home and you reach the college. This is what you have been doing from last, let's say 2 years. So what you do tomorrow morning 9 o'clock, you will do the same thing. This is the human intelligence. But if you put it in the data, what time with respect to time and your activity, every day you do 9 o'clock, and if you ask the machine to predict, it will predict tomorrow morning 9 o'clock, you will do that. This is a kind of a machine learning. So for that you need a data. Okay. So the data sourcing and processing the data, because if you want to have a very good machine learning model, the data is most important thing. So because if you have a wrong data, you may get the wrong results. Then we need to train the models. There are very different types of machine learning models. So once we identify the good data, if you train the data and if you use the right model, you without doing anything, any experiments or any calculation, you can predict the properties. So that is the idea of machine learning. But finally, we should have experimental validation. Otherwise, whatever we do, this loop will not complete. Okay. So this is the ecosystem that everybody wants to set up now, so that the time for identifying the better molecules, the time will reduce. So for example, in 1980s, to find a molecule, it may take 5 years. Okay, so that much time is needed because it is a trial and error method, because we don't know, we don't have any visual screening method, so we have to do everything manually. But when the computational chemistry came, that time has reduced to 3 years, because without doing experiment, with the help of computational chemistry, we can identify the potential molecules. Only these potential molecules will synthesize and we will find the best material. So that is why the time taken in is reduced. Now, in the era of machine learning or artificial intelligence, we don't need to spend too much time on anything. I hope you are reading all the news articles. I don't know whether maybe this is the right platform to tell all these things, but you know how Iran president Supreme Leader has killed based upon the simple machine learning data. Okay, so they identified where he will be. They identified the traffic signal data, his movements, everything, and precisely located his place, and Israel attacked on it. So of course I have given the wrong example, but so this is how with the help of data you can identify anything. So the time taking for innovating the right materials will be very less. Okay, because how the experimental science and how the chemistry, how physics is evolving, machine learning data processing also evolving. Previously, the molecules are represented with the 2D type of structures. Like for example, at the end of the day, machine learning is nothing but mission has to understand. So what is the language of mission? Either 0 or 1. You have to convert everything into that language only. So the molecules also we have to represent in that way, that is called Smiles representation. So you can see the benzene can be represented with C1 double bond, so something like that. So this is the mission readable language. If I give benzene structure to the mission won't understand. Correct? So what actually mission does is 3-dimensional data converted into 2D structures. These 2D structures again we can convert into 3D. Now machine learning also, with the help of graph neural networks, we get the more precise information. Okay. So for example, I don't know whether if it is a boron also, try to take this point. For example, in the left side we have a smiles code. What actually shows the smile code is only the type of atoms that we have, and we have a bonds, but it doesn't have the information about dihydrogenase, whether it's a planar molecules or a rigid molecule. That information is not there. But with the help of graph neural networks, we can incorporate much better information rather than the SMILES representation. So that means how we are converting the chemical knowledge to the simple neural networks, that is also expanding. So when we have a more precise information about the molecules, we can predict the properties in much faster way. So this is from the machine learning point of view. So this is the what I was telling. Previously we will go in this way. We have to synthesize the molecules, we have to test, characterize and discover the properties. So this is the normal process. Now in the era of machine learning, we should fix the target first. What property you want. Then we can use any artificial intelligence or machine learning models, and we can identify and we get the final product. That is the SMILES, that is the representation. Once you get that, then we can synthesize the molecule, we get it. So previously we synthesize, get the property. Now in the era of machine learning, we should fix the property and we have to get the molecule. So this is the reverse design. People has established loop we have. But now, because of the computational chemistry, as I told, we can screen the millions of molecules and we can identify the best molecule. And based upon the quantum mechanical properties like a HOMO-LUMO gap or the emission range, vibrational properties, all those things we can use as a descriptors. We can identify the best molecule. So this is the process now we can establish. In the case of emitters also, so I told you the Jablonski diagram, that is the Jablonski diagram. So based upon that, we can design any type of emitters like fluorescence emitters, room temperature phosphorescence, the examples that I showed, EADF, everything has some property. That property we can fix. As I told, in the case of inverse design system, we can design any type of molecules. So previously we can combine some quantum mechanics, the computational chemistry is a standalone thing. Now we can merge with the machine learning. So this will become a double engine type of a strategy. So we can expedite the things much faster. And these are some of the proofs that where the combination of computational chemistry and machine learning has makes the identifying the better molecules. I'm not explaining all those things, but if you see here, so how we see the data, how machines see the data, you see the left side, we have a 934 molecules data, okay, which is difficult for us to analyze anything. But the same thing, if you put it in a graph neural networks, then it will give the better representation. So where human intuition has a limitation to identifying the better molecules, we can, with the help of machines, we can identify the better features, the type of systems. So now you see, now people has reached to a stage that previously what we have done is, for example, there is a family of molecules, like for example benzene. I want to design a fluorescence molecule based upon benzene family, a class of molecules, and we do modification to it. But now I don't want to put that effort also. It's not effort, there is a bias, okay? So I may like to do on only one type of material. So I'm actually biasing. I don't want that also. What actually we can do is, we can give entire chemical space. So there are different type of molecules. This side we have a different type of molecules. We can ask AI to design itself, okay? So for example, take all halide compounds, take all alcohol compounds, then you will have thousands of molecules. So based upon that, it will screen the molecules, okay? So this function is not there choosing the molecules. So we will have a much more potential systems in the systems. So I am skipping all these things. So this is how we can start our room temperature, our fragments. These fragments can act as a library. Can generate the library of molecules. Machine learning can pre-screen it. Quantum mechanical will do the first level of screening. Then we can go for synthesis. So this is the flow chart of designing or accelerating the materials discovery. But the problem with this also, like as I told, the data is more important, and we should move towards better algorithms for the machine learning. But finally, this is something called self-driving laboratory. So this is like a near long-term goal. So now, if you see even in the case of research laboratories, it's when I identify the molecule, people has to synthesize that molecule. But if you have a kind of a robotic labs, so robotic lab can integrate with the machine learning and a generative AI. So if you want to have, you can just input the property what you want. So the robot itself do the machine learning. Robot itself will do the quantum mechanical screening. Once it identifies the potential molecule, it itself will do the synthesis also. Okay. So you may ask how robot can synthesize. Yes, it will happen very soon. Then finally you will have a product. So this is what in a very near future it will happen, where human intervention will be very less. I think if you have a doubt, you search in the China. There are something called dark industries. Dark industries in the sense, they don't need any light in the industry. Why we need a light? Why we need light here? Because we are here. Okay, in the dark room we cannot sit now. But who can sit in the dark room? Machines can sit. Okay, they don't need light. Okay, so there are some factories where human intervention is zero. That is a car manufacturing factory. So everything is done by robots. Okay, car designing, everything designing to the manufacturing is fully done by robots. This is called dark factories. So soon it will come into our days also. So that is why if you want to survive in the society, you should have either more intelligence than the artificial intelligence. Okay, your natural intelligence is the only savior of your survival in this society. Okay, so I'm stopping here. So thank you for organizers for inviting us. Any questions you have?
If you have any questions, you can freely ask. Everything clarified. It's fine. Sir, I have it. We have machine learning tools, computational tools for drug discovery and design, like showing so when we design the molecules,
Mani on ji mic.
And after getting molecular docking studies, IDME analysis, all these things, we can able to predict the molecule and its efficacy on target for a particular disease. How much percentage we can expect the accuracy when we come to experimental identification of the efficacy of the drug after screening, after using the virtual tools?
So the accuracy is depends upon how carefully you are doing the virtual experiments.
Actually, we have done some molecules, we have designed some molecules and went for synthesis, and then we screened the molecules. So during docking and ADME, all these things, we have done excellent results when compared to the the standard molecules. But when we go to actual picture, when we tried it in laboratory, the efficacy of the molecules fall down to 30 or 20%. So when we synthesize 20 molecules out of 20, 2-3 molecules they have shown better efficacy. But in virtual screening, it is reported most of the molecules reported higher inhibition on the target. So how can you solve these issues, sir? How can we predict the molecules more accurately, better than these tools? Do you suggest any other tools to screen the molecules other than these molecular docking and ADME, all these things?
No, it's all depends upon how critically we are doing the visual screening. The first thing, okay? As you told, it's a tool. The tool also you have to use carefully, right? Otherwise, it may not give the expected properties. So, like you should understand how the tool works. Then only you can get the maximum outage of better results from the tool. And the other thing is, when you do the visual screening, how closer to you are refrigerating to the experimental targets. Okay. So, for example, in the case of docking, it's majorly you are giving the input on the charge. Okay. How better charges you are giving, how you generated the charges first of all. Have you taken the default charges, or you got the charges from the quantum mechanics? So these are the important factors that you have to see how you have done the molecular dynamics, molecular docking studies. And the second thing is, when it fails in the experiment, so you should see where it failed. Okay, so it's always better to have an extra loop. So you have taken the feedback from the experiments again incorporate into the visual screening tools that you are doing, so that next time it may do better job. So that is what we are doing in the machine learning also. So this will help us to improve the efficacy of our screening. So that will always help. And also you can see the literature also, how people has adopted the methodologies, so that you are the chances of getting the better molecules can be improved based upon previous literature and the type of charges that we are taking, how many cycles of docking we have done. And for example, when you take a library of molecules, basically docking is done by the docking score. So how much deviation of docking you got. So for example, you have 10 molecules, docking score, how distributed it is. You got the narrow distribution or long distribution. If it is a narrow distribution, potentially you have taken the same type of molecule. So there is a chance of losing all the decks gone wrong. Okay. So how much diversity you have. So that kind of a little more analysis is needed. So there is no straightforward answer. Unfortunately, we have to do more rigorous and meticulous study. Then only the efficacy will be more.
Thank you, sir. Thank you. Any doubts from audience?
Sir, one question, sir. Up to now, we are synthesizing molecules and doing characterization. After that, we are seeing applications of those molecules. Present studies, no, sir. Now we are going to artificial intelligence. So, for example, particular property we want to get it. So we are giving data, and automatically, as per you, system will generate the molecule and so and so. After certain time, if the software fails, I think there is no need to do experimental work. As per your artificial intelligence, system will generate automatically potential molecules, and based on application, directly gives the molecule. Actually, previous days we are doing number of trial and errors. After them, we are saying applications of the molecules. So a lot of waste of time is there, waste of material also there. But as per you, artificial intelligence directly gives the molecule. It has better application. But after certain time, if it fails, the software will fail or system will give wrong data, then how can we justify whether it is correct or not?
So
Which is the better one, earlier research work or current research work, which is out of these two, which is better, how can we justify?
So which is better is actually, so that is what we all strive for, right? So for example, there is no guarantee for anything.
Yes.
Okay, so there is no. So then if it is a no, if it is a guarantee thing, it's not a research. With respect to process thing, so you have to take off until the experimental validation as a suggestion only. Okay, so for example, if you are targeting a drug, okay, so you have to choose a potential molecules. Within that, again, you have to do the synthesis. Then only you identify the potential molecule. So that is one way of, avoiding the risk of completely failing the experiment. So if you end up with only one molecule, if you synthesize that one molecule, it may change chances of getting failed. So instead of that, you take your potential molecules. So there is a chance of succeed will be little higher. So that is one way of looking at it. And the second thing is, these are the screening things. So there is nothing called failed or succeed. Okay, so it is always a process. It will keep on improve. That is what I told. The more accurate data you give, the more quality results you get. So if you give any wrong inputs, you may get wrong, misleading data. So that is why data is more important, and that is the reason nowadays data is more valuable than anything.
Whereas most of the people are implementing our systems, even for small calculations also, we are not using our.
No, you will see in near future, you will get NMR spectra also will be internet related. Machine learning will do the NMR spectra.
Okay, sir.
Thank you very much, sir, for your nice talk on advanced research on machine learning and artificial intelligence tools. Thank you, sir. Now it's time for felicitation to our guest. I request Dr. Mahesh sir to come forward to receive our honor. I request all faculty members, please join with us.
వెనక్కెళ్ళు పడతావా వెనక్కెళ్ళి ఇప్పుడే నాకేం తెలియదు. వస్తాను
మణికంఠ మణికంఠ
The next session, there are moral presentations.
చూసుకుంటా చూడాలి. మెయిన్ క్యాంటీన్ అది ఎంతమంది చెప్పారు ఈరోజు?
So it's the time for oral presentations. Now I invite Mr. M. Anil Kumar to present his research.
Good morning, respected chairpersons, judges, my dear friends. My name is Anil Kumar Reddy. My name is Anil Kumar Reddy. I am currently pursuing MS Organic Chemistry in this college. I have a strong interest in areas like nanotechnology, spectroscopy, and green synthesis. I have a work on this topic such as the green synthesis of nanoparticles using plant extraction. I am here to today present on this topic. On the topic photofabrication of zinc-based nanoparticles using Portulaca glandiflora leaf extraction. A green root wave of zinc is taken for structural characterization of functional assignment. Introduction. Portulaca glandiflora is commonly called as mushroom. In Telugu states are called tenocla flower. It belongs to Portulaceae family. It is fast growing and herbaceous plant and native of South America, in widely growing in tropical and subtropical regions including India. Nanoparticles are particles within size 1 nanometer to 100 nanometers. It enhances of quantum enhance and catalyst in reaction rate of increases. Botanical classification. Kingdom is plantain, division is Malgolinium tritum, class is Malgolinaceae, space, order family is Photolithicaceae, genus is Portulaca, species is Portulaca grandiflora hooks. Uses of Portulaca grandiflora leaf extract. Used in traditional medicines and exhibit antioxidant, anti-inflammatory and antimicro. It containing of vitamin A, C, E enhanced. Phytochemical constituents, flavonoids, alkaloids, phenolic compounds, tannins and antioxidants. Nanoparticles. Nanoparticles are particles in size within the size 1 to 100 nanometers. Nanoparticle synthesis. Top to down or bottom to up synthesis. This one is top to down. Bulk amount of the nanoparticles to small nanoparticle pieces are prepared, or down to top, bottom to up, and atoms to cluster to nanostructures are formed. Spark coagulation nanoparticle synthesis. దీంట్లో స్పార్క్ లైట్ అనేది యూజ్ చేయడం వల్ల హైలీ యాక్టివ్ ఎలిమెంట్స్ లైక్ జింక్, సిల్వర్ ఇలాంటివి ఐడెంటిఫై చేస్తాం. Different types of nanoparticles. A nanoparticle can be classified into different types according to the size, morphology, and physical and chemical properties. Carbon-based nanoparticles is made up of the carbon. Example is graphite, fluorine. Example used for electronics and energy storage. Metal oxide nanoparticles. It containing metal and oxygen atom. Example for zinc oxide, titanium oxide, ferrous oxide, and uses in sunscreens. Applications. Application drug delivery and skin treatments which are catalyst and reaction chemicals lo use చేస్తారు. Water purification and pollution control కి యూజ్ చేయడం జరుగుతుంది. Objective. The object of the present work on this topic to prepare the zinc nanoparticle by using leaf extraction, Portulaca glandiflora, commonly called as moss rose. with solvent of different polarities, water and methanol. In characterization of UV, IR, XRD, same. Methods and materials. Majorly in synthesis used for zinc acetate, dihydrate solution and distilled water and methanol and used to make chemicals. Photolacca gradiflora leaves, where in campus gown. Next one, leaves in cut chase small pieces and crush after heating the 80 degrees centigrade for magnetic stirrer for 40 minutes. After preparation, plant extraction are prepared and zinc acetate solution and two solutions are mixed. Magnetic stirrer at 70 degrees centigrade for 30 minutes. After completion of time, centrifuge it 3500 rpm for 15 minutes to prepare zinc oxide nanoparticles while bottle is formed. Phytochemical analysis. Test for phenols. Latest test. Some amount of 1 ml of zinc latest test and 1 ml of plant extraction to form precipitate. White precipitate is formed phenolic presence of phenolic compounds. Test for flavonoids. Sodium hydroxide test. 20% of sodium hydroxide is collected with 1 ml and add the acidity of HCl and change the color, yellow color, to return the presence of flavonoids. Test for alkaloids. Result: formation of nanoparticles UV visible analysis. 350 to 800 nanometers is confirmed.
Last year.
UV visible spectroscopy show characterization of absorption peak ranges 350 to 380 nanometers is confirmed by zinc-based nanoparticles. IRD analysis. Functional groups OH and functional groups indicate role of photochemical reducing stabilization. XRD. Typically 20 to 50 nanometers peak range, corresponding of hexagonal structures of zinc oxide nanoparticles. SIM analysis. Morphology structure, this one. Antimicrobial activities in processing. Mechanism of green synthesis. Photochemical presence of Photolacca gradiflora act as reducing agent containing +2 to zinc oxide nanoparticles. Copying agent. Stability of nanoparticles are present arrangement. Conclusion. The present studies been successfully and responsible for protocol of eco-friendly green synthesis of nanoparticles. These are references. Thank you. Any questions? Thank you.
మై షీట్ తీసుకురమ్మా వీళ్ళిద్దరు చేత
A very good presentation, Nani.
ఈమన్ వాళ్ళు
Next I call
తీసుకో ఈమన్ షీట్
Ibrahim and his team to present their presentation.
Good morning everyone. We are here to present our project titled The Concentric Circle Ring 4-foot MIMO Antenna for 5G applications at 28 GHz and 38 GHz. Okay. My name is Murali Krishna and my teammate Ibrahim. This project is done under the guidance of Dr. Jettis Chandrasekhar Rao sir. Before going into the antenna design, we need to understand the basic concepts. 5G technologies. First, definition of antenna. Antenna is a device which is used to send and receive the data, receive the electromagnetic waves. Next, introduction to 5G technologies. As we all know that 5th generation technology is the latest advancement in wireless technologies. It provides high speed, which means it can deliver ultra fast data transmission speeds up to 20 gigabits per second. It also provides low latency, due to which means it reduces latency as low as 1 milliseconds. It also provides higher capacity, which means 5G is estimated to be 60 to 120 times faster in response time. This is all about 5G technologies. Next one, MIMO antenna for 5G technologies. Multi-input, multi-output antenna is a wireless communication technology which uses multiple antennas at both the transmitter and receiver for transmitting and receiving data. MIMO antenna plays a crucial role in 5G application networks, and this advanced technology significantly increases data speed, network capacity and reliability. It is used in Wi-Fi, IoT devices and for 5G applications. Substrate material. We use Roge's RT Duroid 5880 material for this project. It is a polytetra fluoroethylene based high frequency material which is used for advanced radio frequency and microwave applications. It has low dielectric loss and very low loss tangent, which makes it ideal for mmWave applications, that is 28 GHz and 38 GHz, which are used in our project. This material exhibits excellent thermal stability, low moisture absorption and high reliability. Due to its superior electromagnetic wave properties, it enables high efficiency, low signal loss, and consistent performance. Now, antenna design and simulation results, my teammate will explain.
Good morning to all. It is a 4-port MIMO antenna. It has a size of 33 length and 33 width. It has a thickness of 0.8. It has a bandwidth of 5 GHz and it obtains 11 GHz at 38 operating frequency. It provides an isolation of 26 dB. It offers a peak gain 8.83 at 28 GHz and 8.20 at 38 GHz. Due to the use of the material Rogers RT 5W80, which acts as a smart material by controlling the electrical behavior of the substrate. These are the geometry of the design. The yellow and the blue color is the patch, and the yellow is the substrate. It is the front part of the gel, and the back is the back side represents the ground. It is a trimetric way of the MIMO antenna. Return loss. Now we are going to cover all the simulation results. Return loss. It represents how much amount of power is reflected back to the antenna. It has achieved more than minus 30 dB at both 28 and 38 GHz. It offers a 26 isolation. It represents the mutual coupling between the antennas. It achieves a peak gain of 8.71 and 8.65 and 8.83, 8.72 at 28 GHz while exciting the ports, different ports. And it has achieved 8.14, 8.14, 8.20, 8.09 gain at 38 GHz while exciting different ports. It is a 2D radiation pattern of MIMO antenna at port 1. The red line represents the electric field and green line represents the magnetic field. It is the surface current distribution at 28 GHz and 38 GHz. It is observed that that's the higher frequency, the mutual coupling is affected, the other antenna remains. It is a peak gain plot. We have obtained 8.83 at 28 GHz and 8.20 at 38 GHz, and we have got high radiation efficiency 94% and 98% due to the use of Rogers RT 5W material. ECC, it shows the how independently antenna works due to the effect of the correlation. DT diversity gain, it shows the reliability of the antenna. We have obtained a diversity gain of 10 dB. MEG, it will mean effective gain. It represents average power received by the antenna element. It should be practically less than 3 dB minus 8. CCN represents the number of bits lost per second. TRC represents the overall reflection of the antenna when all the ports are excited. These are the simulation results. These are the comparison of other words. We have given a high peak gain and less ECC. In this one, we have used a constant circular MIMO antenna by using the substrate material RT 5W80. We have achieved a high gain and high efficiency and good mutual coupling in this design. Thank you.
Very good, Umran and team. Next, I would like to invite K. Vishant to present his findings.
Morning friends, I am K. studying final year BTech Mechanical. Today we are presenting our project green synthesis of nickel oxide nanoparticles using fenugreek. Nickel oxide nanoparticles were synthesized via a green eco-friendly synthesis approach using aqueous leaf extract. Our leaf is a fenugreek leaves, trigonal green. As a reducing and stabilizing agent, nickel acetate was employed as the nickel precursor. The phytochemicals present in the nickel leaf extracts include flavonoids, alkaloids, saponins, and phenolic compounds acts as reducing and stabilizing agents during the formation of nickel oxide nanoparticles. The synthesized particles were characterized via XRD, Fourier transform infrared spectroscopy and scanning electron microscope, UV visible spectroscopy test. XRD analysis confirmed the formation of nickel oxide particles with average crystallite size of about 15 to 30 nanometer. FTR results indicated the involvement of phytochemicals in nanoparticle stabilization. Same studies revealed the predominantly spherical nanoparticles with slight agglomeration. The optical band gap was about approximately 3.4 to 3.8 eV. The present study demonstrates a simple, cost-effective and environmental thinking method for synthesizing nickel oxide nanoparticles with potential applications in catalysis sensors and environmental remediation. What is the purpose of why we are using nickel and fenugreek leaves? Fenugreek leaves are primarily used in reducing and stabilizing to synthesize nickel oxide nanoparticles from nickel acetate, which are then applied as fuel additives or combustion catalytes. The leaves themselves are not directly added to the engine, but they help in the biosynthesis step. Nickel oxide particles act as oxygen buffering agents, combustion catalytes, and surface oxidation promoters. This releases active oxygen species that helps in complete combustion of oxygen, reduce unburnt hydrocarbons, better heat release rate, and more uniform combustion. Nanostructured metal oxides have attracted significant attention due to their optical, electrical, magnetic, and catalytic properties. Among these, nickel oxide is the most important p-type semiconductor with wide band gap of 3.6 to 4.0 eV. Having high thermal stability, excellent chemical performance, and catalytic performance. Nickel oxide nanoparticles have found applications in gas sensors, supercapacitors, photocatalysis, electrochromic devices, and antimicrobial agents. Conventional synthesis methods. We can use conventional synthesis methods, but they require high energy consumption and toxic chemicals and environmentally hazardous agents. The types of conventional synthesis are sol-gel, hydrothermal combustion, chemical precipitation, thermal decomposition. In recent years, synthesis using plant extract has emerged as a sustainable alternative. Plant extract contains diverse phytochemicals such as flavonoids, polyphenols, saponins, alkaloids, terpenoids, which acts as reducing and buffering agents, which eliminates the usage of conventional synthesis methods. These are the materials we use: fenugreek leaves, nickel acetate tetrahydrate, sodium hydroxide, and distilled water. They are of analytical grade and used without further purification. Preparation of leaf extract. Fresh fenugreek leaves were added to 100 ml distilled water and heated at 70 degrees Celsius with continuous stirring up to 30 minutes. The mixture was cooled and filtered using Wattman number 1 filter paper. The extract was stored at 4 degrees Celsius. Phytochemical constituents of fenugreek. The phytochemical constituents are biologically active secondary metabolites that help in green nanoparticle synthesis. These phytochemicals act as reducing, stabilizing, capping, and chelating agents. Reported flavonoids are quercetin, camphor, vitexin, isobutexin. Next, functional role in nanoparticle synthesis. The functional role of flavonoids. These are strong reducing agents, reduce Ni2 plus ions during nanoparticle formation, provide antimicrobial properties, stabilize nanoparticles via hydroxyl and carbonyl groups. Alkaloids. Fenugreek leaves are important in alkaloids such as trigonelline and choline. Their role is metal ion complexation, surface stabilization, improve the dispersion of nanoparticles. Alkaloids contain nitrogen atoms that coordinate with metal ions. Saponins, the reported saponins are diazigenin, hemogenin, act as natural surfactants and improve colloidal stability. Saponins provide steric stabilization due to their glycosidic structure. Next. Reported phenolic compounds are gallic acid, caffeic acid, chlorogenic acid. They act as capping agents of nanoparticles, enhance oxidation, antioxidant activity. Tannins are, the reported tannins are related to polyphenolic compounds. Their role is strong metal ion chelation, formation of stable metal organic complexes, act as capping agents. Next, terpenoids. Terpenoids are also related to phenolic groups, bind to nanoparticle. Their role is to bind to nanoparticle surface, provide hydrophobic stabilization, control growth rate of nanoparticles. Proteins and amino acids contain amine and carboxyl groups. They control particle size. Next, this is the important phase. Role of fenugreek phytochemicals in nucleoxide nanoparticles formation. There are 4 steps in this. First one, complexation. Ni2 plus ions from nucleus state interact with hydroxyl, carboxyl and amine groups of polyphenols, phytophenols, chemicals. Reduction and precipitation, second step. Under alkaline conditions, under alkaline conditions, phytochemicals assist in nucleation control. Next, stabilization. Flavonoids, polyphenols and saponins cap nuclear estate, nickel hydroxide nuclide. Calcination. Upon heating, organic residues partially decomposes, yielding crystalline nucleoxide nanoparticles. Next, this is preparation we done. The precipitate. Fenugreek leaves were added dropwise to the nickel estate solution. The pH was adjusted to 9 to 10 using 1 molar of nickel with sodium hydroxide solution. The green precipitate was filtered and washed thoroughly with ethanol and dried at 80 degrees Celsius, and further calcination is carried out at 300 to 500 degrees Celsius. These are some of the pictures we captured during the process. Okay, results. UV visible analysis showed the nanoparticles having strong absorption band around 320 to 380 nanometer, corresponding to charge transfer transitions. XRD analysis showed these peaks at these values. These peaks are pure, showing the cubic phase of nickel oxide. No impurity peaks were observed, confirming phase purity. The average crystalline size were observed using Scherrer equation was between 18 to 28 nanometer. In these peaks, we can observe the identification of nickel at these peaks. It is FTIR analysis. The graph shows the FTIR analysis.
I call upon CH Nandini, Secretary Congress to present her proposition.
Good morning, respected judges, dignitaries, and everyone present here. I am C.H. Nandini Safira from CHSD St. Teresa's College. My paper title is Digital Age, Youth in Sandrapadu, Lifestyle, Health and Sustainability. In this project, I discuss on physical health and energy levels. Impacts of junk food. Junk food has been very common among youth because it is easily available and tasty. However, it has several negative effects. It leads to obesity and weight gain. It reduces immunity and energy levels. It can cause digestive problems and long-term health issues. Many teenagers prefer fast food over nutritious home food, which affect their overall health. Impacts of electronic gadget dependency. Today, electronic gadgets like smartphones and laptops are an important part of life, but overuse can be harmful. It causes sleep disturbances, especially due to late night usage, leads to eye strain and headaches, results in poor posture and physical inactivity, can lead to addiction and reduced concentration. Excessive screen time is one of the biggest lifestyle challenges among youth today. Graph analysis. From the data, we can see that digestive issues are about 20 people. Next, about 15 people reported weight gain, and around 10 people reported fatigue, and 5 people no noticeable effects. Moving on to this pie chart. Main reason why people prefer junk food is large portion, 50%, and 20% eat junk food for food convenience, and 10% of people reported lack of healthy alternatives. Now looking at this graph, it shows how often people argue with their family about screen time and gadget usage. Often, next 24% is said sometimes, indicating occasional disagreements. About 22% reported rarely, which means fewer conflicts in some households. 10% said never. This clearly family conflicts. Survey and my field work. For this project, I visited nearly 50 households in Sandrapadu and conducted. This helped me to gather real-life data and better understanding about the situation. The key findings from my survey are high consumption of junk food, especially among teenagers, excessive usage of the electronic gadgets, health issues like tiredness, sleep problems, and lack of concentration. Awareness sessions. To address these issues, I conducted awareness sessions focusing on healthy eating habits, reducing junk food intake, limiting screen time, and maintaining balanced daily routine. After the awareness sessions, some families reduced junk food consumption, many started controlling screen time, awareness about healthy living improved. To conclude, junk food and excessive gadgets use are major problems affecting youth today. However, by making simple changes like eating healthy food, reducing screen time, staying physically active, we can improve our health and lead a better life. This project helped me to understand the importance of healthy lifestyle choices and spreading awareness in the community. Thank you all for your patient listening.
Very good, Nandini, for your presentation. Next, I call upon Dr. Jayanti. Dr. Jayanti. Yes, present. Please share your screen.
Devi from Mount Carmel College. Today I am presenting my project on increasing shelf life of commercial fruits and vegetables by using chitosan-based edible coating from fruit and floral waste. We all know fruits and vegetables which are highly perishable, example banana and tomatoes, spoil quickly. This leads to economic loss and reduced equality. To overcome this, we can use a edible coating which is from chitosan. Why chitosan is it? Because it is a natural biodegradable compound with antimicrobial properties. It forms protective layer that reduces respiration and delays life. So this study focuses on using chitosan coating as an eco-friendly preservation method. The objectives are prepare the plant extract and waste, prepare a chitosan-based edible coating incorporating prepared plant extract, and apply them and study the difference between control and human samples. These are some of the review of the future. Coming to the materials required and methodology. The first part of methodology is preparation of the extracts. The waste material which are using is recipe, dried molecule flowers, and banana peel. These were washed, dried, and powdered. Plant waste is of 10 grams as evident 100 ethanol and accelerated into daisy. Filtered using reinforcement paper to get the pure extract. Second part of the methodology is preparation of chitosan coating. The preparation is simple. 1.5 grams of chitosan was dissolved in 1% lactic acid and stirred on magnetic stirrer for 15 minutes at 50 degrees Celsius. Later, 3 different volumes of the plant extract was added at 5, 10 and 15%. Samples were stirred additional for 5 minutes and at the end, fluoride of 0.75 ml is added as a plasticizer. Glycerol not only makes the increases the plasticity, it also makes the edible coating non-brittle. Sorry to interrupt. Please share your slide. Sorry. Yes, it's visible now. You can continue. Okay. The coatings are after the preparation of the coating, it is coated on the fruits and vegetables. The fruit and vegetable which I choose is banana and tomato with all three concentration. This is for day 1. Here, visibility is seen that it is 10%. The second ingredient is working more better. And the same thing for marigold and the banana peel. Other than shelf life, we have also studied a few parameters. The first parameter is degradability, the coatings with the extracts and the control. It is subjected to soil and checked for the degradability for 10 days, and these are the outcomes. It shows that it is 10% marigold and banana 10% show degradability compared to the control and the other coated extracts. Second parameter is weight loss. The weight loss is checked in terms of grams. Here also the seed 10, citrus 10, marigold 10 and banana 10% shows a reduced weight loss compared to the control and other extracts. This is for the banana and this is tomato. The other parameter is ethylene production. Why ethylene? Ethylene is a ripening hormone. Higher ethylene representation. Overall 10%.
Screen is visible. Please unmute. Audio is not. You are not audible.
Coming to the emotional project, we enter the rational habits of youth and raise awareness among the globalism of social media and improving physical and mental health by ensuring long-term sustainable development. Coming to the objectives, to examine the social media on mental health, behavior, and environmental consequences, and to suggest solutions for making sustainable lifestyle practices in use for long-term health. From the graph analysis, here the graph shows number of people who are choosing social media are highly networking, and some people are using graph using mobile for news updates and staying with family, whereas people are using social media for entertainment. From the second one, this pie chart shows steps to be taken for sustainability from the people. Most of the people consider that environmental education should be useful to take sustainability and learning. The community process and communities are equally shared, and social media campaigns are covered 30%. This is the data they given. Coming to the conclusion for this project, over a period of 4 weeks, I continued. Project, target lifestyle in Ashok Nagar, excessive screen time, often exceeding 5 hours per day, is primarily due to entertainment.
Hello, am I audible?
Yes, sir. You are audible.
So, let us stop. Yes, sir. Sir, is my screen visible? Good afternoon, sir. We are from Prakash Engineering College. We are from Prakash Engineering College. Deep learning, in the sense of working, this manuscript presents a structured comparison between classical machine learning and deep learning frameworks and quantum computing approaches analyzing computational complexity, scalability, accuracy, data loading, constraints, and hardware limitations. While quantum algorithms such as Lewis algorithm and Shor's algorithm demonstrate provable speedups. There is no universal learning and deep learning problems efficiently, which means quantum computing is one type of structure and machine learning is another structure. There is no difference, but in the speed of execution it varies. Theoretical boundaries between complexity classes, practical data encoding challenges and applications. The manuscript concludes that hybrid quantum classical architecture represents the most realistic pathway towards quantum enhanced machine learning. The major keywords are quantum computing, machine learning and deep learning. And machine learning and deep learning have achieved remarkable success in large-scale data-driven tasks, including image classification, speech recognition and scientific modeling. These successes are powered by GPU-accelerated optimization and massive parameter training. Introduction to quantum computing. Quantum computing is an advanced computing paradigm based on principle of quantum mechanics. It uses quantum bits, means qubits, instead of classical bits, those binary bits, to process information. Key features are superposition. Qubits can exist in multiple states at once. Entanglement. Qubits can be interconnected and share information instantly quantumly. Parallelism. Ability to perform many calculations simultaneously. Quantum computing frameworks. Quantum computing states superposition in Hilbert space, entanglement, correlated quantum states enabling parallel computation, interference. Unitary evolution preserves normalization through quantum interface. Measurements yields probabilistic outcomes. P of I is equal to 1 of AI square. Classical machine learning framework. Machine learning and deep learning models optimize loss function, min of N of naught. Example, linear regression, support vector machines, convolution neural networks. Deep learning models often contain millions of parameters trained using statistics, gradient descent, SGD. Computational complexity depends on big O of N of D, where N is equal to samples and D is equal to features. Quantum computing framework. Quantum states in Hilbert space. Quantum systems operate in Hilbert space. Unitary evolution. The evolution of a closed quantum system is governed by a unitary operator in net cell. Complement is equal to union of net cell. Unitary operators are preserved, normalization satisfied, where previously I mentioned in the previous slide. Quantum algorithms for ML. Grover search and optimization with quadratic speedup, where its time complexity is big O of n, errors big O of root n. HHL algorithm solves linear system Ax equal to b in logarithmic time under restrictive assumptions. Matrix inversions. Many ML problems reduce to matrix operation, suggesting potential quantum advantage. Critical limitations. Data loading bottleneck, Pascal data encoding. Net x equal to sum of xi net I requires big O of n time. Often negating quantum speedup entirely. NISQ hardware constraints. Current devices faces limited qubits, decoherence and gate noise. Deep neural network requires stable, large scalable optimization beyond current fault tolerant capability, which means the system requires large amount of softwares and hardwares. Complexity boundaries. No proof that NP or PQP quantum computing cannot efficiently solve all NP hard ML optimization problems. NP means non-deterministic polynomial time. Optimization challenges. Variation in quantum circuits suffer from parent plateaus, gradient instability and measurement noise similar to vanishing gradients in deep networks. And early we have discussed that quantum computing does not replace machine learning and deep learning. Instead, it may accelerate specific subroutines, it offers quadratic speedups for search, it provides new feature representation via Hilbert space. However, data encoding remains costly because hardware is immature and no universal exponential advantage exists. And here I conclude that this study establishes that quantum computing cannot universally solve all machine learning and deep learning problems, while theoretical speedups exist for structured algebra and such problems. Limitations arise from data loading complexity, noise in current quantum devices, and unresolved complexity theoretic boundaries. The future of quantum enhanced AI lies in hybrid machine learning, deep learning, dominate current real-world applications. Quantum computing, and finally I'm saying that quantum computing would not replace machine learning or deep learning. It just modifies some problems where machine learning can't speedily provide the output. But in the sense of quantum computing, it can provide faster output. But the limitation is it can only provide some specific problems only. And finally, thank you.
Okay, thank you, sir.
Thank you, sir. Thank you.
Present, we are concluding the online sessions.
Good afternoon, respected judges, dignitaries, and everyone present here. I am L. Sunandana along with my team members Sri Pradalakshmi, P. Nilima. I am from CHST Teresa's College for Women, Eluru. We are presenting here our topic nanotechnology uses and environmental consequences. Our topic is about and its impact on the environment. Nanotechnology deals with controlling and manipulation matter at every small scale, at a level of atoms and their molecules. It has many important applications like fields, medicine, electronics, and the energy. It also raises environmental corners which we should carefully understand. Nanotechnology study and the manipulation materials at the nanoscale, typically between 1 to 1000 nanometers. At this scale, materials show unique properties such as increased strength and a special chemical behavior. This idea was started and introduced by scientist Richard Clement in 1959. There are so many approaches, nanometers. The top-down approaches reduce large materials into nanoscale structures. The bottom-up approach builds materials atom by atom and a molecule by molecule. To study these materials, scientists use unique ideas like STM, provides highly sensitive rapid detection, hydrogen toxics and contamination tests. Very low concentrations get fast responses and probability make them valuable tools for safety, environmental monitors, and medical diagnosis, enable the early detections and better their protections. Nanotechnologies is revolution medicines through precious drug delivery, improved imaging, and tissue regeneration. Nanoparticles can target specific cells, reducing side effects, while advanced imaging techniques allow earlier diagnosis. Additionally, nanomaterials support tissues, engineering, and regenerative medicines. Advanced cancer therapies. Nanotechnologies offers important cancer treatments such as photodiagnostic therapy and magnetic hypertherapy. Methods target human cells precisely, minimizing damage to healthy tissues. As a result, they provide more effective, less invasive, and safer approaches to cancer treatment. To be continued, Madhu Atla. Nanoparticles, despite their significant benefits, raise important environmental and health concerns. They can enter ecosystems through consumer products, agricultural activities, and industrial waste. Once released, they may generate electro-oxygen spices, leading to oxidative stress and cellular damage. Their tendency to stress and cellular damage. And biological systems can disrupt ecosystems and affect food chains. Future research in nanotechnology focuses on interchanging artificial intelligence to optimize nanomaterial design and applications. Smart drug delivery systems are being developed to respond to psychological conditions in real improving treatment efficiency. Additionally, nanorobotics offers promising applications in medicine and environmental monitoring, while sustainable nanomaterials aim to reduce environmental impact through eco-friendly and biodegradable solutions. Nanotechnology holds transformative potential in areas such as medicine, environmental monitoring, and material science. Its benefits include enhanced drug delivery, improved diagnostics, and targeted therapies. However, responsible innovation and proper regulation are essential to ensure its safe and sustainable use. This is our brief presentation. Thank you for your attention. Thank you.
ఇక్కడ రిలీజ్ అయిన వాళ్ళందరూ మీరు క్యాంటీన్కి వెళ్ళి లంచ్ చేయండి.
ప్రింటింగ్ మళ్ళీ రాంగ్
మనీ నీకు అవసరమా? మీరు లంచ్ చేసేయండి. లంచ్ చేసి వచ్చాక మీరు
మా కూర్చోండి. మీరు కూడా
వీళ్ళు ఇప్పుడు
చెప్పించేద్దాం. కూర్చోండి.
Good afternoon, everyone. My name is Vijay Durga. Today, my topic is design of MLE RUPNS for forensic applications under the guidance of Dr. K. Chandramohan sir, Department of Chemistry, Acharya Nagarjuna University. Green synthesis refers to the design of chemical synthesis methods that minimize environmental impact, reduce waste and energy consumptions, and avoid hazardous substances. Ruthenium is a rare heavy metal, is highly valued for catalytical properties. Mulberry plants are highly valued for their nutritional, medicine, and economic importance. Schematic representation of synthesis of mulberry leaf extract, ruthenium nanoparticles. Dried mulberry leaves powder are dissolved in distilled water and boiling in water bath for 90 minutes and filter the brown solution that is called mulberry leaf extract. Mulberry leaf extract solution was dissolved in RUPNS nanoparticle solution and ruthenium chloride solution and kept it for 2 hours heating, and dark brown color particles are formed that is called nanoparticles. Here the characterization techniques UV analysis and IR analysis. Here the green color peak is mulberry leaf extract and blue color peak is mulberry leaf ruthenium nanoparticles. Mulberry leaf extract. Here the SEM analysis for MLU RUPNS. By using mulberry leaf extract ruthenium nanoparticles, development of latent fingerprints are observed. Latent fingerprints for forensic applications. By using ruthenium nanoparticles, fingerprints are developed. Comparison between latent fingerprints by activated carbon and MLU-RUPNS. By using MLU-RUPNS, fingerprinting results are effective and more compared to the activated carbon. MLU-RUPNS gives the effective results. And another development, fingerprints on mobile phone and other objects. Within a short period of time, we collect these fingerprints by clean adhesive tape, and these are collected fingerprints after 30 hours. By long period of time also, ruthenium nanoparticles developed the fingerprints very clear and effective results. Finally, we conclude that the synthesized RUPNS by using MLE extract via green approach, synthesized MLU-RUPNS shows stable and capping agent with good yield. These synthesized nanoparticles are used developed of latent fingerprints instead of other chemical powders to get better results and less use of chemicals. Thank you.
Okay, I need one clarification. So yesterday your counterpart, one of your friend, presented about magnesium nanoparticles. So what are the comparison results between these? Which one is better?
We did with the ruthenium chloride.
So when compared with magnesium, ruthenium is costlier.
Costly and give effective results.
So, but when compared with magnesium, the results with
ruthenium chloride
are better. So everyone alone cheptaru. Then what is the actual fact? So is there any violation in applications? Ruthenium nanoparticle applications, magnesium nanoparticle applications, what is the difference?
With a long period of time also, ruthenium nanoparticle gives the effective results. After 30 plus hours also gives the, yes, here the example.
30 hours. So what are the kind of samples from which you can collect? So when can we use ruthenium nanoparticles? Under which conditions it is much used?
Forensic applications like crime cases we used. Dye removal.
When we compared with magnesium or some other one, so why should we go with already existing methods? Ruthenium because it is very costly. Then easy ga మనం రెగ్యులర్ గా వాడలేం. కానీ మనం సెలెక్టివ్ గా యూస్ చేయాలి. అడ్వాంటేజెస్ తీసుకురావడానికి అలాంటి కండిషన్స్ ruthenium ఇంకా నార్మల్ కండిషన్స్ మెగ్నీషియం బెటర్ రిజల్ట్స్ ఇస్తున్నాం. రెండు rutheniumతో మనం మెగ్నీషియం ఆప్ చేస్తాం. కాస్ట్ ruthenium మీరు డెవలప్ చేస్తారు యాక్టివిటీ కానీ we have to compare the activity with respect to the other method. ఎలాంటి కండిషన్స్ మోర్ సూటబుల్ సరే చూసారా?
Okay, Amma, thank you. Nice presentation. Next, ముగ్గురు ఉన్నారు. ఇచ్చారమ్మా
ఫోన్
బాగా చెప్పాము అమ్మ మీరు
here to present. Today I'm here to present. Good afternoon to everyone. Today I'm here to present PPT on our research article. The title is Molecular Talking Studies as an Alternative Tool to Predict Drug-Drug Interactions. The main aim is to investigate transporter-mediated drug-drug interaction using molecular talking, focusing on telmisartan, metformin, and atorvastatin gemfibrinogen, with key transporters PGP, BCRP, MRP2, and OCT3. And objectives: predict binding, operation, and affinity of drug transporter protein using autotalk vena, and determining whether telmisartan compactually inhibits metformin at OCT3, PGP, and MRP2 transporters, and evaluating whether gemfibrinogen increases atorvastatin accumulation by inhibiting FDAPS transporters. Validating in silico results against known clinical pharmaceutical observations, demonstrating molecular talking as a rapid, fast, effective screening tool for DDA prediction. And introduction. Firstly, what is molecular talking? A computational method to predict favorable orientation and binding affinity of the ligand upon binding a receptor, forming a stable complex. Next, applications. Structure-based drug design and high thoughtful virtual screening, predicting drug-drug interactions and early orientations of lead compounds. And why we use drug-drug interactions? Many drugs compared to the common transporter proteins or metabolic enzymes, molecular talking helps to identify competitive binding scenarios, predict alternative drug pharmaceutics, guide dose adjustment diseases. So we use the tools of Autotalk, Vena, Chimera, Discover Studio, and Protein Data Bank. The steps involved in the experimental methodology is protein preparation, ligand preparation, diagon setup, autotalk simulation, and visualization and analysis.
A warm good afternoon to dignitaries. I am Sheikh Sania Nishat, a final year student of Madhu Atla College of Pharmacy. I am here to present a research article. The case study we conducted on telmisartan and metformin. The telmisartan and metformin are both anti-hypertensive and metformin drugs. We bind these with their key transporters like PGP, BCRP, and metformin. The binding affinities of telmisartan is stronger than metformin. So the telmisartan binding affinity is stronger than metformin, as it results metformin reduces its bioavailability in the body. Second case is mapping of gemfibrozil and atorvastatin. Gemfibrozil is a lipid lowering drug and atorvastatin is a statin drug. These drugs are binded with the respective proteins like PGP, BCRP, and MRP2. That results in fibrozil inhibits effects on the transporting enzymes and eliminates and inhibits atorvastatin levels. These result in reduced clearance of atorvastatin and increases of accumulation of atorvastatin in the body. This causes high risk of myopathy and rhabdomyolysis. Conclusions. Effects of DDI predictor. Molecular talking reliably elucidates transporter-mediated DDIs at molecular level without in vivo experiments. Telmisartan and metformin shows stronger binding at OCT3 than metformin, indicates competitive inhibiting and reduced metformin bioavailability. In case of gemfibrozil and atorvastatin, gemfibrozil inhibits efflux transporters PGP, BCRP, and MRP2, reducing atorvastatin clearance and raising toxicity risks. Advantages: rapid screening, cost-effective, early DDI identification, validates against clinical pharmacokinetic observations. Clinical impact: findings support dose optimization, improved drug safety monitoring, and better therapeutic decision making during co-administration. Thank you.
Here is one clarification. So we studied the binding between telmisartan and metformin. But I don't think these combination drugs are not so we won't use directly in a single these two are of different activities. Telmisartan is different from metformin.
Metformin. Telmisartan ఇప్పుడు ప్రెసెంట్ అందరికీ
రెండు
వాడుతున్నారు కాబట్టి బీపీకి ప్లస్
ఆ కాంబినేషన్లో అయితే లేవు కాంబినేషన్స్
కో అడ్మినిస్ట్రేషన్ చేసినప్పుడు వచ్చే సైడ్ ఎఫెక్ట్స్ గురించి మాట్లాడుతున్నాం సార్.
నెక్స్ట్ వన్ సో మూడు కాంబినేషన్స్లోనూ టెల్మిసార్టాన్ కామన్గా ఉంది ఓకేగా మూడు కాంబినేషన్స్లోనూ టెల్మిసార్టాన్ కామన్ నేను స్టడీ చేస్తున్నాను
టెల్మిసార్టాన్ మెట్ఫార్మిన్ ఒకటి సార్. ట్రెంఫిప్రిజిల్ అటారోస్టాటిన్
సో both are and statin drugs. Statin drugs. Next yes.
Good morning, good afternoon everyone. I am Muskan Patel, final year B.Pharm student from Madhu Atla College of Pharmacy. Today I am here to present our project research. Our project title name is Development and Antimicrobial Assessment of Pineapple Peel Derived Fermented Product. Now I want to tell about fermentation. First of all, fermentation is a natural process which converts natural sugars into useful products. Pineapple peel is a agro waste which consists of a good compounds like natural sugars, and it has antimicrobial properties too, which helps in fighting against antimicrobial activity. It enhances the medicinal properties and nutritional values. And let's go into the introduction. Aim and objectives. Our aim of our project is to develop a fermented product from pineapple peel waste and evaluate its antimicrobial potential against selected pathogenic microorganisms. And objectives is to collect and prepare pineapple peel as a fermentation substrate, and to optimize fermentation conditions like temperature, pH and fermentation period. And then we have to prepare gingerbread culture which acts as a natural microbial inoculant, and to conduct phytochemical screening like iodoform, dichromate test and Benedict's test on the fermented product, and to evaluate antimicrobial activity against E. coli using nutrient agar medium. Determination of zone of inhibition and compared with the standard drug which is nitrofurantoin 1000 mg per ml. Determination of MIC of fermented product and cinnamon extract at 100, 500 and 1000 microgram per ml concentrations, and to assess stability of our product under different temperature conditions 25 to 50 degrees centigrade for 1 month. An introduction. As the antibiotic resistance is a growing global health crisis, and urinary tract infections affect 150 million people annually worldwide, and conventional antibiotics faces declining efficacy against resistant pathogens like E. coli. Natural fermented products offer promising antimicrobial alternatives. Pineapple peel, often discarded as a waste, it is rich in bioactive compounds. Methodology. In the methodology, first we have to prepare our gingerbread, and then we have to peel the pineapple and adding palm sugar to it, and addition of cloves and cinnamon sticks, and make up in the volume with water, and we have to ferment it for 2 to 3 days until rising of bubbles and sweet odor smell and alcohol smell when we observe that smell. And preliminary screening, we have to perform these 3 tests like iodoform test which confirms the presence of ethanol, and dichromate test which confirms the presence of reducing substances and alcohol, and Benedict's test which confirms the presence of reducing sugars like glucose, sucrose, fructose, etc. And evaluation of antimicrobial test. Organism we have selected is Escherichia coli from our college, Madhu Atla College of Pharmacy from Microbiology Department. And the media we have used is nutrient agar, in which we added agar plus beef extract plus sodium chloride plus peptone, making up to 200 ml. And sterilization with autoclave at 121 degrees centigrade 15 minutes with 15 lbs pressure. And inoculation using spreading technique, incubated at 37 degrees for 24 hours. And the method is couplet method, bores mated with the borer in solidified agar. Concentration we have used is 100 microgram per ml, 500 mg per ml, 1000 mg per ml of test solutions. Standard drug that we have used here is nitrofurantoin, 1000 mg per ml. Incubation 37 degrees for 24 hours. Zone of inhibition is measured in degrees. And the conclusion, fermentation beverage was successfully developed from pineapple peel waste using palm sugar, cinnamon, cloves and gingerbread as a natural fermentation starter. Phytochemical screening confirmed production of ethanol, alcohols and reducing sugars, validating successfully lab-mediated fermentation. pH of our fermented product is found to 4.20, indicates an appropriate acidic fermentation profile consistent with quality standards for probiotic beverages. Antimicrobial activity against E. coli was demonstrated with a zone of inhibition of 10 to 12 millimeters, showing 63% efficacy compared to nitrofurantoin, which is 19 millimeters. Stability testing confirmed no significant change in product parameters across 25 to 40 degrees centigrade over 1 month. Pineapple peel and agricultural waste can serve as a sustainable substrate for producing functional fermented products with antimicrobial potential. Thank you.
So why should you, what is the criteria behind selecting nitrofurantoin?
Nitrofurantoin is the it is a marketed drug which is used for UTI infections. It is an antimicrobial drug.
So actually pineapple waste peel substrate, but you have included cloves and cinnamon. What is the reason?
What is the reason means it also cloves and cinnamon, they are also natural compounds. They also, when we combine them with like pineapple peel, they increase the activity of antimicrobial activities. So that's why we have added.
So they proved to cloves.
New models are updated also.
Research articles.
Recently test చేశారు. Reported.
Yes sir, cinnamon we have conducted. We have prepared cinnamon extract sir. In lab we have conducted by using agar couplet method. It shows antimicrobial activity, cinnamon extract.
Then you can compare the activity of only pure pineapple peel and pure and concentrate. చేశారు.
No sir, we have combined cinnamon plus that fermented product, and we have combined with normal cinnamon, like cinnamon extract, and we combined cinnamon extract with pineapple beverage like fermented.
కాంబినేషన్ తీసుకున్నాను ప్యూర్ పైనాపిల్ తో కూడా కంపేర్ చేస్తాను.
Pure pineapple combination చేసి
పైనాపిల్ ఫర్మెంట్ చేసి సిన్నమన్
వైఫ్ ఆన్ ఆఫ్ ఆఫ్ చేస్తున్నా
అంటే
ఆగిపోయింది ఆటోమేటిక్గా అది.
cinnamon flour అంటే వాటికి కూడా
నేను యాక్టివిటీ వైజ్ మాట్లాడాను. ఇస్ దేర్ ఎనీ రోల్ ఇన్ ఇట్స్ ఫర్మెంటేషన్ ఇన్ఫ్లుయెన్స్ అండ్ rate of fermentation particular
cinnamon
అందరు క్యాంటీన్కి వెళ్ళారు.
సపరేట్
రికార్డ్ అయింది వాయిస్.
pineapple peel extract separate తీసుకుని అన్ని డిఫరెంట్ ప్రపోర్షన్స్ లో మిక్స్ చేసి యాక్టివిటీ చేయాలి.
స్టూడియో పెట్టాను. స్టూడియో
సో ఫర్మెంటేషన్ చేసేటప్పుడు వాటిలో ఎందుకు యాడ్ చేస్తారు అందులో లాజిక్ మీ ఓన్ ఐడియా
సరే చెప్పాలంటే వాటికి కూడా ప్రూవెన్ యాక్టివిటీస్ అంటే లైక్ రీసెర్చ్ ఆర్టికల్స్లో వాటికి కూడా యాక్టివిటీ ఉంది లైక్ ఇన్హిబిషన్ ఆఫ్ సెల్ సో
యాక్టివిటీస్లో డిఫరెన్స్ ఉందా?
యాక్టివిటీస్లో అంటే కొద్దిగా డిఫరెన్స్ అయితే
ఫ్రీ అయినా అడిగిందా?
అర్థమైంది.
యాక్టివిటీ ఉంది, దీన్ని మనం చెక్ చేస్తున్నాం. ప్యూర్ పైనాపిల్ పీల్ ఫెర్మెంటెడ్ ఎక్స్ట్రాక్ట్ తీసుకుని దాని యాక్టివిటీ చెక్ చేస్తాం. when compared with the activity of pure cinnamon extract, ఎలా ఉంది అనేది లేదా యాక్టివిటీ చేంజెస్ ఏమన్నా ఇలాంటి యాక్టివిటీస్
దీనికి రిఫరెన్స్ బయట మామూలుగా చేశారు సార్ టెంపరేచర్ పైనాపిల్ పేరుతో ఇంతవరకు మార్కెటెడ్ ప్రొడక్ట్స్ అండ్ షుగర్స్ కూడా న్యాచురల్ షుగర్స్ అవి యాడ్ చేసి ఉన్న మార్కెటెడ్ ప్రొడక్ట్స్ ఉంటాయి. కానీ మీరు తీసుకున్నది తాటి బెల్లం ఉంటాయి, అది యాడ్ చేశారు షుగర్కి. అండ్ ఆల్కహాల్ ప్రొడక్షన్కి ఈస్ట్ యాడ్ చేశారు. అంటే మార్కెటెడ్లో ఉన్న ప్రొడక్ట్స్ ఫెర్మెంటెడ్ ప్రొడక్ట్స్
మీరు ఒక గ్రూప్లో ఇలా వర్క్ చేస్తామని చెప్పారు. నేను అది ఎందుకు అట్లా సెలెక్ట్ చేస్తున్నాను
అంటే మార్కెటెడ్ ప్రొడక్ట్స్లో ఉన్న డిఫరెంట్ కాంపోజిషన్స్లో మాకు
కొద్దిగా వైవిట్ చేసి లాజికల్గా ఏదో లాజిక్ ఎగ్జాంపుల్ సాంపుల్ ఎందుకు తీసుకున్నాను.
Good afternoon, sir. My name is Koda. I am present pursuing final year B.Pharmacy in Bakatla College of Pharmacy, Bakatla. Today I am here to present my final year project research work. The title of project research is Integrated Pharmaceutical Formulation and Bioactivity Evaluation of Amaranthus spinosus leaf extract using FTIR and molecular docking techniques. Our aim is to formulate a topical emerger using Amaranthus spinosus leaf extract and to evaluate its antimicrobial activity using experimental and docking methods. Our objective is to prepare and screen the plant extract for phytochemicals, to formulate and evaluate the emerger, to study antimicrobial activity, to perform FTIR and molecular docking analysis. Herbal products are used since ancient times for treatment. They have many bioactive secondary metabolites that include alkaloids, flavonoids, tannins, which provide antimicrobial and antioxidant effects. They are important source for drug discovery. 80% population relies on herbal medicine because they are cost effective and easily available. And also they have fewer side effects than synthetic drugs used in prevention and treatment. Main problem in marketed products, raw extracts are unstable, which have poor bioavailability for phytochemicals, and they need controlled drug delivery, improve stability and patient compliance, which enhance therapeutic use. The phytochemicals and their activities present in the Amaranthus spinosus plant are alkaloids, flavonoids, tannins, saponins, terpenoids. Antimicrobial resistance is the major global health problem caused by misuse of antibiotics, leads to multi-drug resistant pathogens. It limits the effectiveness of the drugs used, and the need for new antimicrobial agents, natural antimicrobial agents, is demanded. Amaranthus spinosus is a medicinal plant belonging to Amaranthaceae family, traditionally used to treat infections, inflammation and skin disorders. It shows significant antimicrobial, antioxidant and anti-inflammatory properties. The plant is rich in bioactive compounds like flavonoids, alkaloids and tannins. Commonly known as spiny amaranth, it grows widely in tropical and subtropical regions. In Telugu, it is called as Mulla Totapura. Emerger concept. We prepared herbal topical emergers by using emulsion, by combining emulsion plus gel base, which is suitable for topical drug delivery, and it enhances the lipophilic drug penetration through skin, provides controlled release, and improves spreadability and stability. The excipients used are carbobol, which is a gelling agent, tween-80 emulsifier, liquid paraffin oil phase, triethanolamine pH adjustment. For forming a gel, triethanolamine is needed. That means gel is formed in alkaline pH only. So triethanolamine is used for pH adjustment. Methyl and propylparabens are preservatives. As we adding herbal extract to the gel aqueous base, which will loses the gel formulation. So we have to use compulsory preservatives for preparing. Methodology involves collection and drying of plant leaves, extraction using Soxalate apparatus, phytochemical screening tests, preparation of emulsion formulation, evaluation and antimicrobial